Allison was not a major hurricane, and it was only getting started. Allison did not stop in Texas. Over the following 2 weeks, the storm crawled across the Gulf Coast and up the eastern seaboard, dropping heavy rain from Louisiana all the way to Pennsylvania. By the time it finally dissipated, it had killed 41 people across 6 states. The geography of those deaths tells you how far the danger traveled. 23 in Texas, 8 in Florida, 7 in Pennsylvania, 1 each in Louisiana, Mississippi, and Virginia. Here is the detail that matters most. 27 of those 41 deaths were caused by drowning and freshwater flooding, not storm surge from the ocean, not wind, freshwater falling from the sky and rising in the streets. Most of those people were caught in the most ordinary way imaginable. They were in their cars or in low spots when the water rose faster than they understood. This is the part of flooding that defies human intuition. It takes remarkably little water to kill. 6 inches of moving water can knock an adult off their feet. A foot of water can float a car. 2 feet can carry away most vehicles, and water can rise from a trickle to a torrent in minutes, often when the heaviest rain is falling miles upstream and racing downhill toward a person who is standing in sunshine. The most common fatal decision is also the most reasonable sounding one. A driver reaches a flooded road that does not look deep, on a route they have driven 1,000 times, and they decide it is probably fine. That decision, on roads exactly like the ones in Houston, is what filled the casualty list in 2001. The most lethal place is the underpass, the spot where a road dips down beneath a railroad or a highway. It is the lowest point for a long way in every direction, so when the water comes, it fills that dip like a bowl, sometimes to a depth of 10 or 15 feet, and it does it fast. A driver approaches in the dark and sees what looks like a shallow sheet of water across the road, because the surface of a full bowl looks exactly like the surface of a puddle. They cannot see that the road drops away underneath. People have drowned in their cars and underpasses they had driven through thousands of times in the dry, a mile from home, in their own neighborhoods. The water does not announce itself, and the rain that produces it is often falling somewhere else entirely. And it raises the obvious question: how does a storm this week kill this many people when far stronger storms sometimes kill far fewer? The answer comes down to a single equation, and once you understand it, you will never look at a storm forecast the same way again. Total rainfall equals rainfall rate multiplied by duration. How hard it rains times how long it rains in one place. That is the entire secret of flood lethality, and almost everything dangerous lives inside that multiplication. A powerful hurricane brings a high rate, but if it keeps moving, it spreads that rain across a long path, and no single town absorbs all of it. A weak storm that stalls does the opposite. It takes a smaller rate and multiplies it by hour after hour after hour over the same ground, and the product of that multiplication can be a disaster. Allison was not a strong storm. Allison was a patient one. It stood over Houston and let the equation run. The stalling is the multiplier, which is why the single most dangerous word in any flood forecast is not the word hurricane. It is the word stationary. There is a second reason a stalled storm is so dangerous, and Allison showed it clearly. Think of the ground as a bucket. The first inch or two of rain fills the soil, soaks in, and runs into channels that still have room. The land can handle that. But once the soil is saturated and the channels are full, every additional inch has nowhere to go but up, into the streets and the homes. A storm that keeps moving gives the ground a chance to drain between rounds. A storm that stalls never does. It keeps pouring rain onto a surface that has already given up, so the third round of a multi-day event is far more dangerous than the first, even if it does not rain any harder. That is precisely how Allison worked. The early rounds did not look catastrophic. They simply filled the bucket so that the final round had nowhere to put its water except into people's homes. This is the terrifying truth that Allison exposed, and it is worth saying plainly. The strength of a storm and the deadliness of its flood are two different things. We measure the first and ignore the second. And because we ignore it, the weak storms keep catching us. They will keep catching us until we learn to fear the slow ones as much as we fear the strong ones. There is a reason we keep making this mistake, and it is built into the tool we use to measure danger. The hurricane scale that everyone knows, the categories 1 through 5, is the Saffir-Simpson scale. It is a measure of wind speed, and nothing else. It says nothing about how long a storm will sit over a city. It says nothing about how much rain that storm will produce. In other words, the number we all use to decide how afraid to be is measuring the wrong thing for the hazard that kills the most people. Watch what that does to human behavior. When a Category 4 approaches a coast, the number is high, the fear does its job, and people evacuate. When a tropical storm or a depression approaches, the number is low, and people stay home, go to work. and drive the usual roads, reassured by a scale that was never designed to measure their actual risk.